Hey everybody, I put together a nice little 9 weeks review, so let's go through it. First thing is momentum. Momentum is mass in motion. It's dependent on the mass of an object and the velocity of an object. So the two ways that you can change momentum is either change the mass or change the velocity. It's not the same as inertia. That's important to remember. The equation is P equals mv, P, the ability for it to progress, equals momentum, measured in kilogram meters per second, made up of the mass in kilograms multiplied by the velocity in meters per second. Everything on that page, important to remember. Couple of conceptual questions that you will want to keep in mind. What happens if you exert a larger force on the object? There is a larger change in momentum. There is a small change in momentum. There is no change in momentum. There are puppies. So, test-taking strategy right away. We know that puppies is not the correct answer. There's no change in momentum is not going to be the correct answer because we're exerting a large force. This is talking about the concept of impulse, which is equal to force multiplied by time. If we increase the force that we are applying, then we are going to get a larger change in momentum. So A would be the correct answer there. What happens if you exert the same amount of force for a longer amount of time? Again, looking at our concept of impulse, of force multiplied by time. If time stays the same and we increase the time, then what's going to happen? We're going to have, again, a larger change in momentum. Impulse is that change in momentum we just discussed. It depends on the magnitude of the force and the duration of time that we apply that force. The equation J equals change in mass or velocity, that's just the change in momentum, is equal to force in time. Okay, same units as momentum because it's just a change in momentum. A little situational question that you see here. The delivery truck's going down the highway. When it notices the brakes are out, the driver knows that he has to hit something in order to come to a stop. He sees two choices, a brick wall or a pile of hay. Which one should he choose? Well, the brick wall is going to have a very small time interval, which is going to have a very large force interval, whereas the hay is going to have a long time interval for the stopping, which is going to decrease the force that the truck is going to have to put up with, and therefore stop in a much nicer way. So he would try to pick the hay instead of the brick wall. The change in momentum is still going to be the same for both. The change in P or the impulse is going to be the same. The only thing that we can change is we can decrease the force by increasing the time and make it more hospitable to come to a stop. A little video on conservation of momentum on the internet. Check that one out. Talks about the different collisions and the concept of conservation of momentum. I can't talk about it any better than he can, so check it out. ISS, nice NASA video. Law of conservation of momentum basically states that the total momentum before a collision has to remain the same after a collision. We talk about a closed system. I define here the system is the objects that we're interested in. External forces are forces outside of our system, so we're only worried about those internal forces, and we're worried about closed systems because they're always going to have momentum conserved. Here's an example of where momentum is conserved. We have a 1 kilogram object traveling at 3 meters per second, which gives it a momentum of 3 kilogram meters per second. We have another 1 kilogram object traveling at 1 meter per second, which gives it a momentum of 1 kilogram per meter per second. When they hit each other, equal and opposite forces are going to apply to each other. A little bit of momentum from number 1 right here is going to be transferred to number 2 right here. So some momentum is going to go to number 2, and afterwards we're going to see number 1 has slowed down and lost some of its momentum, and number 2 has sped up and gained some momentum, but the total net momentum before and after the collision is the same because momentum is conserved. Our types of collisions, big thing to know about these is the definition of each one and how to use these equations, okay? Perfectly inelastic, remember this equation. Anytime two things are stuck together, we're going to see how we need to add the two masses and they're going to have a combined velocity. The football player and the ball become one complete object. We have mass 1 of the football player and mass 2 of the football that will come together to make an overall mass in this equation. Remember this equation, know how to use it. Look up problems on the internet if you need to. Elastic collisions, basically the same equation as the inelastic, but this time they're going to bounce off of each other and all kinetic energy is conserved. There's just a difference in the definition for those. The equation's still the same. Know how to use that equation though. Here's a practice problem we're going to go through so that you can make sure and know how to use those equations. A 2 kilogram blob of clay moving at 3 meters per second to the right slams into a 4 kilogram blob of clay that's at rest. Calculate the speed of the two when they stick together. This is that perfectly inelastic collision that we were talking about. So we're going to use the perfectly inelastic collision equation. We have mass 1, velocity, we have mass 1 and velocity 1 plus mass of object 2 and object velocity number 2, which is equal to, once they become together, we have the mass of one object and the mass of the second object together, and they're going to have a combined velocity. So we'll call that velocity prime. So 2 kilogram blob moving at 3 plus the 4 kilogram blob that wasn't moving at all equal to the 2 kilogram blob plus the 4 kilogram blob going at some unknown speed. So this is going to be 6 plus 0 equal to 6 times v. So 6 equals 6v. Divide by 6 to get v. These are going to cancel out. 6 divided by 6, velocity equals 1 meter per second. And that's our answer. So we're going to do another example problem here, this time using the equation mass of one object times the velocity of one object plus the mass of the second object times the velocity of the second object is equal to the mass of the first object after plus times the velocity of the first object after plus the mass of the second object after times the velocity of the second object after. So in this case we have a 1.5 kilogram car traveling at 5 meters per second plus a 3.2 kilogram truck moving negative 4.1 meters per second, negative because it's moving to the left. The two cars bounce off each other. Velocity of the second car afterwards, 1.5 times 8.2, but that's going to be negative because it's going to the left. And we want to know what the final velocity of the truck is. So its mass is still 3.2, and we just want to know what its velocity is. So when we do a little bit of computing here, we end up with negative 5.62 on this side, which is equal to negative 12.3 plus the 3.2 multiplied by our velocity that we're trying to find. So then we're going to add 12.3 to both sides. These are going to cancel out, and we are going to get 6.68 is equal to 3.2 multiplied by our velocity. So if we divide by 3.2 on both sides, these are going to cancel out, and velocity is going to equal 2.0875, but we will round to 3 digits, which will be 2.09 meters per second. Know how to do a problem like that. That's our elastic collision. Next, we'll talk a little bit about waves. The waves and sound unit. Remember that the velocity of a wave is equal to its wavelength multiplied by its frequency. The frequency is how many humps there are per second, or how many squiggles there are. The equation for that is cycle per second, or frequency is also the inverse of period. Okay, so remember those things. Also remember how to determine wavelength and how to compare wavelengths. Determining wavelength, we can go from crest, ignore peak, that's crest to crest. We can go from the exact same spot in the middle to another exact same spot. Remember that this is only half a wavelength because this one was going down and this location is going up. We have to go to the exact location where it's going down again. Or you can go from trough to trough. 3 different ways to find the wavelength. Know what wavelength is, how to find it, comparing wavelengths of different objects. Remember, we just talked about frequency. Remember that frequency is measured in hertz. That's Hz. Hertz. Remember that the amplitude right here is related to the intensity or the energy that a wave is carrying. So in the event that it's a sound wave, that's going to be how loud it is. So the larger the amplitude, the louder it is. I think that's most of the stuff you'll need to know about sound waves. Talking a little bit about the electromagnetic spectrum, remember that all these waves travel at the speed of light, which is c, 3 times 10 to the 8 meter per second. Okay, remember that as we go to the right on the electromagnetic spectrum, as we go this direction, we see a gain in energy. Okay, energy increases with frequency, so the frequency increases and the energy increases. Radio waves are not harmful to you where gamma rays are because of this energy and frequency increase. Remember that as wavelength increases, frequency decreases, and vice versa. Remember that in electromagnetic waves, we don't measure frequency in hertz, we measure it in gigahertz and megahertz because they're much larger values, 10 to the 20 and 10 to the 4th. So remember that. I think that's a good overview of that. Just look over your notes on the electromagnetic spectrum. Looking at plane mirrors, remember the law of reflection is that the angle of incidence is equal to the angle of reflection. Okay, and that means that the distance that you are away from the mirror, let's say that he's 3 feet away, or she, and then the object that you're seeing in the mirror is going to be 3 feet as well. Okay, so if this is 3 feet away from the mirror, the image is going to appear 3 feet into the mirror. Remember that. Remember that mirrors work on reflection and lenses work on refraction. Know the difference between